Dear third year students, very good morning. Welcome to your new semester. In this semester, you have one course with the name Power Electronics 2. Very interesting course. And you are lucky that this course will be taught by Dr. Adil Sarwar sir. He is having lots of experience in the field of power electronics, starting from UG to research level. He has published lots of paper in reputed journals in this field. So it is a good opportunity for you to learn this course with Dr. Adil sir, and congratulations to all of you for this opportunity. Be connected with each and every part of this lecture series. So starting from today, hopefully 40-50 lectures will be there to cover the entire syllabus of this course. I will also try to attend as much as possible to attend these lectures to gain to enhance my knowledge in this field of power electronics. So I will request Dr. Adil sir, please start the very first lecture of this course. Adil sir.
Okay. Thank you, Afroz sir, for giving me the opportunity to start this lecture. So basically in this course, which is Power Electronics 2, and it will be taught to the third year electrical engineering students, we have to cover DC to DC converter and DC to AC converters, and we will also be talking about the power quality aspect of inverters. So these three major topics will be covered in this course. So let me start officially this course. So basically power electronics is a major area of electrical engineering, and we could see that it is now being used almost in every branch of electrical engineering. So I will spend some time in explaining the usefulness and the application of power electronics in electrical engineering from now to next 10 minutes. Okay, so let's see. So I have drawn a block diagram, I have drawn a flow chart here, and I have tried to show the areas of electrical engineering in broad terms. So we use electrical engineering in power generation, then transmission and power distribution and utilization. So starting from power generation, we know that power that is being generated, it is generated in two ways. One is the conventional way of generating power, and it includes thermal power plants, then hydropower plant, and the nuclear power plant. So these are the conventional methods by which electrical power is generated. So you must be knowing that although the bulk power throughout the world is being generated by these three resources, but they do have some negative impact on the environment. Moreover, there are certain shortcomings associated with these type of conventional way of generating electrical energy, which is causing concern throughout the world. What are those shortcomings? The first being the availability of these resources. So if I talk about the thermal power plant normally employ fossil fuel resources for the generation of electricity. These fossil fuel resources are not uniformly distributed throughout the world. So it creates a monopoly between different countries, and which ultimately lead to conflicts, which we are actually seeing around us. And moreover, apart from that, they are not uniformly distributed. The other thing is that they are limited in nature. So if we go on exploiting these resources to meet our energy demand, then time is not far when we are not left with any of these resources in the world. For example, take the case of coal. If we go on utilizing this resource with the present rate of consumption, then it is not going to last for, say, for after 200 or 300 years. So all the coal reserve will be depleted. Similarly is the case with other fossil fuel based resource like your oils. Coming to the hydropower plant, before that, one more thing to note here is that in process of generating electricity by way of the fossil fuel based power plant, the environment gets polluted. So this is again a big issue and big concern for all the citizens of the world, and because of the concern, now government is taking steps in this direction. So environment gets polluted when we rely too much on thermal power plant for the generation of electricity. Then comes the then comes your hydropower plant. So the kinetic energy stored in the flowing water in river is basically utilized for generation of electricity. So this is the basic principle here. But again, developing these hydropower plant requires a lot of area and lot of manpower and lot of investment. Moreover, here also there is an environmental concern, and that concern is the area where the dam is created, it submerges the other maybe populated area around it. So the population has to be displaced from that place. So this is an issue. Then comes the nuclear power plant. So nuclear power plant, although it was a big thing some decades back when it was developed, and people thought that this could provide the energy for the future. But we do see that these nuclear power plants do have very serious limitations, especially concerning the security, because these can be used to develop lethal weapons like nuclear weapons. Moreover, there is again an environment concern, and we do have seen in the past that incidents like what happened in Chernobyl and then 3 Mile Island, and more recently in Fukushima in Japan. So the leakage of the radioactive rays from these power plant poses health hazard to the population. So although we do depend on these 3 conventional sources of generation of electricity in a big way today, and bulk power is coming from these resources, but they are not a sustainable source of generating power. So saying that, now let us focus on the other method of generating electricity, which is the non-conventional method. So non-conventional method involves wind power, solar, and there are others also, and normally they are renewable in nature and they are available throughout the world, so no monopoly because of the availability of the resource. And the best thing about it is that in due course of generation, the problem of pollution it do not come, as which is associated with the conventional power plants. So these the wind power plants and the solar power plant, they are going to be the backbone of energy generation in our future. So basically I am talking about what is the role of power electronics in each of these areas of electrical engineering. So I am basically talking about right now about power generation. So let's see how power electronics play a role in power generation. So if I talk about say wind power or say solar power, in both the cases the power that is generated, say in case of a solar power plant, so solar can be utilized in two ways. So the thermal power plant, solar thermal power plants are there, wherein the heat content of the sunlight is utilized in generation of electricity. The other way of generation is solar PV, solar photovoltaic. So in solar photovoltaic power plants, what happens when light falls on solar PV panels, it generates DC electricity. Okay, and these panels, lot of them are connected in series and parallel, and significant amount of power can be generated by them. Okay, and they are either utilized locally, which is called what we call isolated way of using solar PV electricity, or the other way is your grid connection. It is also called non-grid connection, so wherein the load is directly fed by the solar PV plant. Okay, so in both the cases, since the form of electricity that is generated by the solar PV plant is DC in nature, it has to be converted into AC to feed it to the grid. So here comes the role of power electronics. So the DC electricity generated by solar PV plants is converted into AC and then fed to the grid with the help of inverters. Okay, so let's see here. So this is say there are lots of these panels, and they are first converted into DC to DC converter is there, then DC to AC converters are there, and then it is fed to the grid. So this way power is transferred, the DC power that is generated from the panel, it is a DC converter is normally employed here. I have shown here because we need to ensure that maximum power is being extracted from the PV panel. So I am coming to it, why this is required, why can't we simply use this converter, and why this additional converter is required. I am coming to that. Before that, just see how power flows. So DC power is generated by solar PV panel. This is PV panel, and this panel changes the voltage level. Some V1 voltage is here, it changes to V2, and then a DC to AC inverter is there, which is feeding power to the grid. So just you see that power electronic converters play a role here. Now come to this point, this block. So this is a DC to DC converter. What happens? Let me erase it. Okay, and let's talk about the characteristic of a solar PV panel. So you see a PV panel has got a highly non-linear IV characteristic. Okay, this is IPV and this is VPV, and this is your panel, and the voltage that is appearing across the panel is VPV, and the current coming out of the panel is IPV, then it is moved further. Okay, so if we try to plot a relation between IPV and VPV, we will find that it is non-linearly related as shown here. And if I multiply these two quantities, I will get the power that is being generated out of the solar panel, and it will look something like this. Okay, so just you see here, there is only, this is power PPV. So this is only, there is only one point on the PV characteristic, this is P and this is V. There is only one point on the PV characteristic at which maximum power is available. Okay, so what is the problem? If I am directly connecting this panel to some load, say I am taking a R load, okay, and IV characteristic of an a simple R load is a straight line. So if I try to draw a straight line here, this line, okay, so it is connecting the IV characteristic of the panel here, fine. Then okay, so if I extend this line here, you see that it is connecting the power point at this point somewhere here, so which is less than this power. This power is less than this power, okay. So although this power can be extracted out of the panel, but because of the load line, it is not extracting maximum power, but it is extracting lesser power, okay. So if the resistance would have, the load line of the resistance would have passed through this point, then only we would have got the maximum power. So how to ensure that this load line passes through this? That can be possible if we this load is fixed, we cannot change it, okay. So we need to introduce something in between the load and the panel. So DC to DC converter is normally introduced in between, so it switches the load, and the load that appears to the panel because of the switching corresponds to this R max, say, and this ensures that maximum power is extracted out of the PV panel, okay. So again you see here DC DC converter is a power electronic converter, and how it is playing a role here in generation, power generation part of the electrical engineering, okay. Now let's move to the second part, the power transmission. The power transmission of electrical energy is in two ways normally. So the more conventional and more famous EHV AC transmission, or HVAC transmission. Normally HVAC transmission means extra high voltage AC transmission is there, and the second being your HVDC transmission, okay. So power is generated at the power station, but load centers are located far away from the power generation area, and you know why, okay, because the power generation cannot be within the city, okay, because it requires lot of space. Cannot a thermal power plant cannot come up within a city, okay, because of pollution and large space requirement. So there are various reasons. Similarly, if hydropower plant you want to you are building up, then it requires a river, some source of water, flowing water, so that is normally away from the load center, the city center. So power has to be transferred or transmitted from the generation point to the load point. So this power transmission is normally done either by the help of AC grid or your DC grid, okay. And there are two ways, EHV AC transmission and EHV DC transmission system. So now what is the role of power electronics here? So in HVDC transmission, okay, what happens? Power is generated in AC form. It is first converted to DC. Before that, the voltage level is enhanced also, so as to reduce the transmission losses. Then it is rectified, and then this DC power is transmitted to the receiving end, okay, and then it is inverted back to AC, okay, and then it is given to the load after stepping down the voltage, okay, fine. So here comes, this is rectifier and this is your inverter. These two are power electronic converters, okay, requiring power semiconductor devices, okay. So so this is again the application of power electronics in power transmission. Similarly in EHV transmission also, there are multiple problems faced by AC grids like voltage swell, sag, and then reactive power compensation problem is there. So that has to be taken care of, and more recently fax devices are used to mitigate these problems. What are fax devices? They are nothing but power electronic converters. Okay. So these are the applications in power transmission. There are many other, okay, but we restrict ourselves to these two applications here. Then come to the power distribution and utilization part. Now power has been generated and it has transmitted to a long distance to substations, which are normally very near to the load center, and again power level is reduced further to say normally 440 volts, and then it is distributed to the industries and to the homes. Okay. And so in homes and in industries, if you look around you, you will see many things that work on electricity, but there is a problem. The problem is that the availability of the voltage level and the power level do not match with the equipment that runs on electricity at our homes, even in industries. Okay, say for example, take the case of a simple mobile or a laptop. Okay, so there is a battery within them. Mobile has got a battery, laptop has got a battery, and they are regularly charged. Okay. Now for the battery requires DC voltage and DC power for charging. Okay. And what is available to us is AC power, 230 volts, 50 hertz AC supply. So that needs to be converted into DC form, then only we can charge the battery of the mobile or the laptop. Here comes again the role of power converters and normally rectifiers. So what you call the chargers which are in the mobile, they are nothing but rectifiers which convert the AC supply into suitable DC supply to charge the batteries. Similarly, take the case of say your cooling system is there, then your fans are there. So there are times where you require that fan should run at high speed, say in summer, or at times you want that fan should run at slower speed. So speed control is an integral part and has to be there. So again, power electronic converters are there, which are normally called AC regulators, and they reduce the AC voltage level, and thereby they reduce the speed at which these fans rotate. Okay. And if we talk about the industrial process also, we have induction machines, and many of the industrial process require induction machines, and the speed control is an integral part there itself, and power electronic converter again play a important role there. Okay. So these are the areas which encompasses almost all of electrical engineering, right from generation to transmission to utilization, wherein power electronics play a big role. More recently, we have these EVs and EHVs, electric vehicles and hybrid electric vehicles, HEVs, coming up in a big way, and we will see in future that the cars and many transportation system are going to be replaced by these electric vehicles and hybrid electric vehicles, again because of the environmental concern. So there also power electronic has a big role to play. Okay. So these are some of the applications of power electronics, and you will appreciate it that these application encompasses almost all fields of all branches of electrical engineering. Okay. So for an electrical engineer, it is essential and important that he should have a very good understanding of power electronic converters and power electronic devices in order to design, in order to use it effectively for some purpose. Okay. So I hope the application part of power electronics is clear to you. So although I haven't gone into the details of what is expected and what is the syllabus of the course that we are to study in this semester, and I will be taking that up in the next lecture. This lecture was basically an introductory lecture and to tell you the importance and application of power electronics in the areas of electrical engineering. I hope you have liked the lecture. Thank you.